Okay.
This is my 5th year.
Third.
Third.
This is my first year.
Okay.
This is my first year.
Okay.
And then it's
No,
a cool
wait,
hat.
This is my 6th year. Yeah.
Wait, this is your
First.
yeah. It's like a spaceship.
You guys have a presentation or?
Yeah.
Yes.
Go ahead then.
We're almost ready.
Whenever you're ready.
Okay, Billy, you want to start?
Well, some robot facts are it has 4 large motors and 2 light sensors and a gyro sensor, but we didn't even use the sensors.
Okay.
One of the most challenging things about this robot was the forklift. Because we had to keep taking it apart and putting it back together again to make it lighter, stronger.
Our strategy is that we started off with figuring out what the most points, least points were, and then we figured out what is the easiest with the most points, and then we put it into missions, what we could do in the least time to get the most done to get the most points.
So for our design of the robot, we decided we wanted to make a brand new robot from scratch, but we based it off of all the professional FLL people usually have a base square box robot because they can hold bigger attachments. So we decided to base it off of that and then build our own attachments.
The robot has a cage, so all the attachments go onto it.
Okay.
We had it with the pushing attachment for one is held by 2 pins like there and one over here.
Cool.
With programming, we started out with a pseudocode and plugged it into a Mindstorm, and we tweaked it until we got it right.
Okay.
Our innovation is the attachment cage and the reversible forklift.
Okay. What do you call it? The reversible forklift. Go ahead.
Because it can go both ways. It can work both ways.
Okay. How many legs do you guys have? How many different programs?
We have about 2 programs, but each program does about 2 or 3 missions, which is one.
Sure. Yeah. So I see you have in here. You have the number of. You have run 1 and run 2. Is that the different legs we're talking about?
Yeah.
And I see you have points. Did you total the points, or you know what it would have if you had points? All that. Anyway, I can do the math. You say you don't use your touch sensor, your light sensor, or your gyro sensor. Is that correct?
Yeah.
All right. Could someone show me? So when you talk about your pseudocode, how do you determine? Hey, I want this thing to come out this far. How do you decide that?
Well, we discovered a new thing on the robot. We can go to port view, and we can push the motor. We can push the robot, and the motors will turn, and it'll say, this is how many degrees the wheels have to turn to get it there. And it's a lot simpler than rotations, because there's a lot less math involved instead of dividing inches and centimeters and
Sure. How
everything
accurate
like
have you found that to be?
Pretty accurate. It takes a lot shorter time than standard rotations. It's a lot more precise, and sometimes we do have to tweak it a little, but usually not very much at all.
Okay. When I went through what you have in front of me here, you have this air drop, weights, solar backup. Is that why is there four of those?
Well, the first one we do is that mission, which does those 3 missions right there, but we combine those onto one. Sometimes a part of it doesn't work on it, and so we have a backup program for it that does it a lot faster, but doesn't do a certain thing. So that's just a backup if it doesn't work the first time.
Okay.
The weights we tried to do, but we actually couldn't.
Oh, okay.
And then the 4th one is just the second mission.
So the ones that you do, are they all in this thing called drop, or?
Yeah, the drop is food production, and the lander touchdown.
Okay, could you show me, you say you have 2 legs, could you show them to me?
Yeah, the one is, oh, this is not good. And so let's travel. Yeah.
And if it doesn't, if it's looking like it needs help, go ahead and help it. What is it supposed to be?
It didn't,
Yeah, go ahead and help it if you can.
yeah.
Show me what it's supposed to do. If it works, it doesn't work, not a big deal, I just want to see what it's supposed to
Well,
do.
it's supposed to,
Hit this. It looks like this right now.
That's fine,
yeah, this entire,
it's all right.
Who broke
oh,
the
it's
robot?
on upside down, that's why.
Who put the robot on upside
We
down?
reversed the.
All right, just show me what it's supposed to do.
So it's supposed to come up here and this pushes
Someone
this
put
up
the reverse forklift on.
and
Okay.
it knocks that down. This piece right here hits
Pushes
the
that.
solar
Yep.
panel and then the forklift lowers these down right here and then they kind of drop down.
Okay,
This thing is supposed to bump this up.
Yeah, but-
sure, okay. Is there another leg?
Someone switched it over to the
Yeah,
reverse.
that one that I'll show you.
Okay. Is it possible to get that thing over?
Going-
Ah, I see.
I don't want it hurting my goat.
Yeah, and then,
Gamer now faces, so we have like a reverse piece.
Yeah,
yeah, and so, no, we don't put those on.
you were doing it differently.
Yeah. Where's the dock?
I didn't bring it.
Okay, so,
We're just
Just
gonna
show us
have
how it
to-
works.
We're
Yes.
just gonna have to wing it on this part.
Sure, that's fine.
it's about there,
About there.
and that's how it works. So this one's supposed to do food production and lander touchdown.
Okay,
Hopefully it works.
make sure you help it.
Oh God.
Nope.
Goat.
But it's supposed to kind of hit that,
Yep.
uh,
How does it
and,
know to stop on the green?
we just have it go a certain
Okay.
distance. And sometimes, for some reason, it'll go a little bit more or a little bit less, but most of the time it will land on green.
It's just a look.
Right, and then the lander touchdown, the basket right here is supposed to catch it when it drops the hook and bring it back to base.
Okay. So is there anything in here in the notebook that you want to make sure that I know about? Because I might not get time to read it, so if there's a
The
page.
robot's name is Goat.
Goat, all right.
Yeah.
I named
Gotta write that down.
We all like Goat.
We've all voted on goat.
Greatest of all time is what GOAT stands for? No? Okay.
It just means Goat.
We just like
It
goats.
ramped into this when we were practicing,
Okay.
and
She
it makes
called
a
it
lot of
boxes.
noise.
She called it boxes.
Do you have an
I read
example?
Originally.
goats.
You mentioned your pseudocode. Do you have an example of that you used in here? or-
Did we bring it?
That's fine.
Yeah?
All right.
Oh, it should be, it's right there.
That's it. Yep, I see it. Okay.
Yeah, there's our pseudocode. And then we've got the programs on the robot and comments to show everything that we do on them.
Okay. All right. That's all we have time for, so